Hi everybody. Thanks for joining us for August's Automationeers Assemble gathering. So to improve the audio quality, please remain muted unless you intend to speak. And thanks for being on time. Please note this gathering is being recorded and live streamed, and the video will be made available to watch later. I'm Dave Hunt, Engineering Manager for the Firefox Performance Testing team. I started the gatherings as a way to keep up with the latest projects and practices, and the format is a monthly gathering with a guest to talk about a project they're working on or a passion of theirs. Please join the Automationeers channel on IRC or Slack. They may be used for sharing resources, and I will also be monitoring for any discussion or questions that may come up. So I try to schedule these meetings every month. The times and dates do vary depending on the guest's availability. Next month's is actually going to be in just 2 weeks' time, where Giles Duboc will be joining us from the Wikimedia Foundation to talk about his involvement in a large-scale study of Wikipedia users' quality of experience. There's currently availability for October through to December, so if you are interested in being a guest, or if you have an idea for a guest that you'd like me to reach out to, please let me know. As usual, we may not use up the full hour, and hopefully there'll be some time for questions towards the end. So if you just joined us, I'd like to remind you, please remain muted unless you intend to speak. And note that once more, this event is being recorded and live streamed. So our guest today is Kyle Lamakowski. Kyle is an automation and tool statistics and visualization engineer and is based in Toronto. Kyle's going to be talking to us today about ActiveData, which is a public-facing centralized query service for Mozilla data. So without further delay, I will pass you over to Kyle to learn more.
Thank you, Dave. My name is Kyle Lamakowski. I do a lot of work on ActiveData. So I'm going to discuss what it is, what the major components are, and what the capabilities are. And then, and if you can, try to keep your questions to the end, because I find the video lag as a conversation on video is a little bit disjointed. So we'll put all the questions at the end. Just write them down so you don't forget them. All right, ActiveData. I'm going to split this talk up into 3 major sections. The service section, data, and analysis. The service is all about just making sure that you have your data just a function call away, either from an application or live if you wish. The great thing about a service is it handles all the redundancy, the backup recovery, security updates. It's great if you could just abstract away and have somebody else deal with it. But it's also a centralization point. Data, the data is important. It has to be shaped right and located properly. What are the names of the fields? How does it relate to other data? Things of that nature. And analysis. Because we're talking about centralizing this data, we want to plan to do something with it. And usually the rules or the analysis that we want to do gets complicated. So what type of solutions do we have in that space? So the first part is the service, and you could certainly use a database as a service. It is just a function call away. You probably have a database already. You're probably filled with the data that you're maybe interested in. But there are some problems for using a database as a data warehouse. The queries that you want to do are going to consume resources. They're going to take time. They're going to block your other transactions that might be on that database. It does not contain everything. As much as your database might be all the knowledge it needs to do its work, it does not contain the rest of the enterprise's information. Sorry for using the word enterprise, but it really does apply in Mozilla's sense. A database is also strictly typed. So we're going to have to be specific and manage that manually if we're going to use a database. There's also way too many choices in terms of a database. What one-to-one relations do you make? Do you use nulls? Do you index a column or not? There's do you denormalize in order to make your queries faster, but then slow down your transactions? And a few other things. Next. So we're going to look at Elasticsearch. Elasticsearch is good because It's not transactional, so it doesn't block other queries from running. So it has low query latency. Everything's already indexed, so you don't have those choices of what to index or not. Scales multiple machines. We are dealing with the data warehouse, many billions of records. We're definitely going to have, it's not going to fit on one machine, or if it is, it's going to be insanely expensive. And let's go into more about Elasticsearch. But Elasticsearch, as much as it serves as to be a good central repository, it does have some problems. And that is, first of all, you can't expose it to the public. It has no security. The latest version does, but I don't know if it's a model that works for us yet. So you're going to have to put some sort of service in front of it anyway. The query language is meant for text searching. This is not good for the type of analysis we want to do. If we do go with Elasticsearch, we're going to have to set up our own or pay for another service. That means operational costs and the data transfer costs are required. Many machines, if we do, which we manage, that can become expensive. And Elasticsearch is known for its out-of-memory exceptions, which don't happen very much anymore. So what is Elasticsearch? We'll go over that, over the very good feature of Elasticsearch and reason why we use it. If we want data, if we have our data and we have multiple machines, how are we going to spread this data out? And Elasticsearch solves that problem. It splits the data into shards. Just a second, I see that the delay is a little behind. Split the data into shards. Yeah, okay, there we go. And then for every shard, we can make a copy of it. So we have the primary shard and replica shard. And then Elasticsearch will distribute them over the nodes. And we're done. So this is really neat because if we lose a node, Elasticsearch will, when there is a node available, copy in the shards and repair the whole thing up. And this is good because now we don't have, and these are hot replicas. So all you have to do is add a new machine and the cluster rebalances. So it takes care of a lot of the operations costs. Now, like I said, it has some limitations. So in order to take care of the limitations from Elasticsearch, we have ActiveData. And it will be the public gateway. It will handle the multitude of machines, and it'll also handle all the importing of data from the various sources in order to do the centralization that we want. It will also simplify the data model and the query language. And we'll go over all these. So here is a display of the active logical layout of ActiveData, which isn't showing again. It's a good thing I have two of these. Is the screen updating for everyone else?
I see.
Do you see the logical?
I see service ActiveData as the title and a small architecture diagram in the top right. Okay.
All right. So we're going to put this diagram in the top right in order to discuss about the various components that are listed in there. Two parts are, there's a spot manager. So in order to manage the variety of machines that are going to be needed, both many on the Elasticsearch cluster and also the ETL machines, we have Spot Manager. It's responsible for looking at spot instance prices, making a bid, and then when the bid is successful, setting up the machine. In the event that we do lose machines, it's responsible for making sure that there's always enough machines for whatever workload it's doing. So it takes really three major things. First is a mapping from every AWS instance type into a utility score. That's how much value it provides for whatever job that you want it to do. The current desired utility and the script to set up the machine. So the ETL machines are anywhere from 10 to 250, and its maximum spend is set to $2 an hour. So a logical model really looks something like this. let's look at this utility score. So these are in configuration files. We see each instance type on the left, and on the right we see the utility score for each. In this case, each ETL machine, its utility is based on the number of CPUs it has. And the current desired utility, here's the function for that. All it really says is we'll have 100 machines, or sorry, 100 CPUs, or 100 utility points when it's during a busy day. But other than that, we'll keep it down to whatever our queue is divided by 20. And the script to set up the machine. This is just one part of the script. In this case, we're setting up supervisor. We're copying in the supervisor config file, but we're also updating the number of processes or copies of the ETL process that we're going to be running. In this case, just equal to the number of CPUs. But of course, on the bottom right, you can always see that there's a link to even more if you're interested. The ES machines, again, another instance of Spot Manager. It's about 40 machines, something like that. Its max spend is $4 an hour, but really works out to $3 in actuality because it has to overbid in order to be successful. Here's a general configuration file for it. Just like the ETL machines, they also have a configuration file, but less interesting. You can see here the budget is the $4 an hour, and I'm pointing, but you can't see where I'm pointing. And then also the uptime. You see, it looks over a history of 1 week. It looks at the pricing over 1 day and bids the 95th percentile, so that for the whole week, for any day, it's at the 95th percentile for pricing, which makes it bid high, but is less likely that there's going to be somebody bidding higher than you and you lose your machine. And again, the Spot Manager needs a mapping from every instance type that you see on the left, and on the far right, the utility score. In this case, it's the amount of memory the machine has, or the amount of hard drive space it has locally, local hard drive space, whatever is the minimum. And the required utility is just set to some number, so it's always the same, as much as possible. And again, the script is set up in the machine. So in this case, there's one part of the script, and I got to learn that you have to use fdisk if you're the very first user of the local drives. I went years without knowing this, but when I started setting up a new instance type, sure enough, you need to, well, or parted, that came with the machine, so I'll use that. So the Spot Manager could use some extra work. It needs a test suite, but running the tests actually costs money, so that's a conundrum. And it would be great if there was an actual data source with all the instance types in them and the properties that they have, so I don't have to put it into a config file. There's the ES shard balancer. So we saw Elasticsearch balance, just make copies of the data, or shard the data, copy it, and distribute it over nodes. And as the nodes blink in and out of existence, they get copied in and distributed evenly. But unfortunately, the Elasticsearch shard balancer, it assumes that all the shards are the same size, all the indexes are the same size, and all the machines are the same size. So what we get is, in practice, because there's many different types of instances in AWS, many different types of machines in the cluster, we have some machines might be smaller than others. Some machines have all the big shards and other machines have all the small shards. So there's a mismatch balancing. And the ES shard balancer is what's responsible for making sure that they're balanced according to what the capabilities of the machine are. So it handles the diverse machine types and the diverse index sizes. And then the exact transform and load. So it's a program that gets run on each one of the ETL machines. Its job is to take data from the various sources, transform it. ETL stands for extract, transform, and load, where we're extracting it from, let's say we look at this one, tree herder. We extract it from tree herder. We transform it a little bit. We're going to have to do some actions on it before we put it into Elasticsearch. Specifically, what we're doing is pre-joining the data or denormalizing it, which means we take each job and we join in the option collection hash, the failure classification, all the build platform, job group, job type, so that we have all the data that we would want to join logically to a job as part of the document. And we're also, in the same time, standardizing the data shape. Like I said, in a database, you have too many choices. There's lots of choices to make, but here in a denormalized database, you have very few options. You do not have nulls. You do not have one-to-one relations. One-to-many are strictly nested object arrays. You have no choices for many relations inside of document store, because that would require joins and a few others. Good. And the front end. And it's responsible to be the public-facing service. It will simplify the data model, which you're going to see shortly. Also, it's responsible for presenting the simple query language, but also has to consider the whole business needs. So this is where I want to talk about, for a moment, enterprise design patterns. So when we make services, we should consider all our customers. But sometimes you can't even consider all your customers. Your customers might be unknown or too varied or too diverse, or too varied, or unknown. So there's some patterns that you can apply when you're in that situation. And we're going to go over these three, which is transactional versus analytical, which I hinted about, moving code to data rather than moving data to code, and machine compostability. So those who are not familiar, there are two major paradigms in data storage. There's your transactional database and your analytical database, or data warehouse. And there's two common names for them. There's a relational database management system if it's transactional, but we use the word data warehouse when it's analytical. The data inside a transactional database is usually normalized, so there is little redundancy, but analytical, we want it denormalized because we want to get rid of joins. Transactionals, a lot of small transactions, whereas analytical is more about large batches and long-running queries. And one thing, the reason why these two are usually separated is because we want our transactional system, who is responsible for business, daily business operations, to be fast, whereas an analytical database is for running long-running queries, which might lock up the data store for a long time. So you can't put both in one. And if you try, you'll end up with, you'll end up making two inside of these two major patterns inside one data store. There's also moving code to data and not data to code. We're dealing with large data. Moving it is expensive, not just in time, but also in dollars. So it would be great if we could actually move the code to data and do the processing there. And we want to try to use that pattern as much as possible. We do that because data locality is important. Eventually, the code and the data do meet somewhere. So since the code is much smaller, it's much easier to do. But we also have the benefit that the queries can be done by an existing service already, instead of whatever small application you might want to build. This makes your client lighter and cheaper. But in order to do this, we're going to have to establish what type of primitive data operators there are. Like if we're going to send code, then we're going to have to talk about what that code is that we're sending. And machine compostability, this is just the desire that whatever we do build, it will be simple enough that machines can construct it. And we'll see that SQL is not that. So let's look at our data. If all the data is in one spot, then we have some particular problems. We don't control the type systems because we're ingesting from many other systems or that we are not responsible for. We are at the mercy of whatever they are, whatever their new types or data structures are. And they're changing often because as as an application develops, it's changing. And we also want to be processing unclean data too. We don't know, it's not necessary that we pull our data from other machine sources. We might be getting them from key entered data sources also. And so one of the ways that we're solving this problem of unclean data is this is the model that we use in order to make what looks like unclean data, clean data. The first thing is everything's an array. If it's a null, it's an empty array. And if it's a single value, it's an array of just one value. That way we're only dealing with arrays. And the great thing about this way of looking at data is that we can now separate the code, whatever function we're sending from the data. So with array programming, we have some conclusions that we have to make. One is that property access is null safe. This is good because JSON necessarily does not have all the properties you would expect it to have. So you want to program whatever operators you're sending, you want them to be elegant when dealing with nulls. So array programming, as a consequence, you get this null safety. A single object, let's say that this A is actually an array of an empty object. And if we dereference it by name, we're actually doing an array operation on A. And it turns out that because a list that contains none is the same as none itself, which is the same as a list. So everything's empty here. We also have to conclude that equality is set equality. And this is not obvious. As much as there are many procedural languages let null equal null, and it's not necessarily true, but it has to be true here. All right, so array programming gives us some features that we need, but also type JSON. So we have to deal with these data warehouses or data stores that require strict schemas. And we don't want to necessarily manage that schema because we have so many to deal with. So what we want to do is have everything be JSON. And how do we map from JSON to these strict type schemas? If we can do that, then we can automate it. And we do that with type JSON. So we got five documents here, 5 objects on the left, and each one has a property A, but each is a different type. And we can see how we store these as an actual document in the document store. For every type, like for instance, true, we store it as an object where the binary value is true with an extra property. And you'll notice that we can put these all in the same data store now because they're all named differently based on their type. Now, you're thinking, these are bigger. That's no good. But if we have if we use a columnar data store, we're not actually storing these objects at all. It just means that the names are longer. We're just using different names. So we have more columns, but only by name. Well, except this one example here. Sometimes we want to count if the object actually exists and is empty. That's usually not the case, though. And the great thing about everything is a JSON object is that we can actually store these other examples. We can store arrays of arrays, and there are still objects that fit into Elasticsearch. And same with just strings, they are still full documents. Okay, so now we have array programming and type JSON in order to conceptualize what we're doing with the data in order to put it into a strict data store. And then we want to take the data out, and that's with JSON Expressions. So we want to move the code to the data because the code is necessarily smaller. But we have to determine what is that? What code are we sending? And so if the code is JSON, then that's good because everything's JSON. we want to, if we're sending the code to the data store, then the data store does all the work. Great thing about JSON is it fits in your JavaScript and Python files naturally. You can use it to communicate between applications, and it's relatively simple. If you are a list best expert or know one, then they'll tell you about all the benefits. So I don't just use it for ActiveData or even just sending to other services. I also use it for, here's an example, JX to Mozilla REST. So you'll see it also in the graphics dashboard. So JSON expression, but it first comes from Elasticsearch. This is where I prefer to. What it is, it's the name of the operator. And in this case, we're saying the term build is search, and JSON is very simple.
Kyle, you're breaking up for me, wiping quite heavily. Is that just me, or can everyone else hear?
I can't hear him at all either.
Kyle, if you can maybe try and rejoin the room, that might help.
We want to send instructions that are overall set. So we get them in certain people. Where is your call? And you have to appreciate the data, group by, sort, we from your use. JSON purposes is no scope because we already have we have next. We've got
Okay, sorry about that. Hopefully Kyle will be able to rejoin and his audio will be better. When Kyle comes back, was that 1 or 2 slides back that we need him to skip?
Hello?
Hey, that's much better. Sorry, Kyle, you were
where was I lost?
You were unintelligible. Probably about 2 slides back from where we were.
With the SQL?
Yeah, I think that's about right. Let's go from there.
All right, sorry everyone. I thought maybe by coming into the office, my network would be very stable and something like this wouldn't happen, but of course. All right, so we have so the question is, if we're going to send code to data, what type of operators do we want to send? And we want to send operators that operate on whole arrays of data. And so we get inspired by SQL for this. We have like what table we're going to select from, how we're going to filter, how we reshape the data, how we group, and sort if we want. And anyone familiar with SQL would know these operators. But there is the benefit that we have no joins or explode because we've already pre-joined the data. And in a document data store, we're storing nested object arrays. So here's an example document. It has an array of just one object with the property A, and it has a nested objects with B in it. We can actually select from inside this nested object array. And here we're just selecting the value B, and of course we get this 2. But also notice that instead of using explode or join, we use dot delimited paths into the nested object arrays. And also notice that a data store is logically another JSON object. So JSON expressions, why use those? Why not just SQL? Well, SQL does have some problems. First one is it is capable, you're capable of sending it computationally unbounded requests, and that's because of the join. So here we request a billion rows from a 1,000 row table. And you can make it worse. So there are non-SQL solutions to this. There's always timeouts. But it's not part of SQL. SQL's redundant. Notice that you're going to have, whatever you group by, you also have to mention in your select clause. If we run this query, we would expect that we get a list of all the continents and the number of employees in each, but we don't. Antarctica is missing because there's no employees in there. So how about we right join with the continents so that we get all the continents? Excellent. We'll run that query. Now Antarctica exists, but there's more problems. The EU is now missing. Asia's double counted. We still don't have a 0 for Antarctica, so we're going to have to transform that still yet too. And that is because if we look at the continents, it turns out we have this duplicate entry in there. Maybe that doesn't happen in a production database. Oh no, it happens in a production database. So you can't deal with messy data. You have to be very careful with SQL. But there is a solution to this, and it's MDX. So in this case, we're going to make the same type of query, but this is an MDX. It is, you get to declare whether you put your values along rows or columns, which is nice, because essentially we want pivot tables. And in this simple query, we get everything. We get the whole domain, and we actually get numbers instead of files. And so that's another type of operator we'd like in JSON query expressions, edges. And that's inspired by MDX. We count the whole domain, we count everything, and only once. There's also window, which is a window subquery that can add aggregates to each one of your output records. So we have a few primitive operators to act on arrays of data. And we have a few implementations. The JX Elasticsearch is a core of the ActiveData service. You'll see that right in the core of ActiveData. But there's JX Python. It's used for just local processing. In the event that you happen to have a JSON expression and local data, you still want to process it, so it handles that. And there's also a project, JX SQLite, where you can pour documents into a well-structured database. It uses the type JSON and uses JX to query them out again. Now, future work, it would be great if we had compound queries, because when it comes to analysis, analysis can be complicated, and ActiveData cannot handle complicated queries. It does those few operators that I showed you. You can aggregate and select some subset of the records, but you can't do just about anything. So it'd be great if you could compound these queries, because then you have a lot more expressiveness. And also, we have a large amount of data in ActiveData, and we have a large number of features or columns in ActiveData. So it seems to be a prime candidate for machine learning in terms of what type of operators should we be sending to ActiveData so that it can perform what machine learning operator or machine learning processes you want to perform. But I have no idea what that would look like. But I do have a student project proposed that would look at it in the most simplest sense. And for the future of active data, well, the reason I'm making this presentation in the way that it is because you can now see all the different components of active data, the philosophy, and the data structures that it uses. Because as a project, as a combined project, it may not exist forever. Because there's Google BigQuery. Now it's interesting because it charges by the terabyte scanned for each query. And the storage is so cheap it's almost free. But it's an interesting model. But it serves many of our purposes. Like it is a service. It can be centralized for the destination of all our data. It can offset query load from our transactional systems. It does have SQL, so it can handle complex expressions. But we do have some problems. We don't know what the latency is like. We don't know how this pricing model is in practice. We still have to manage a schema because it is strict schemas. And we also have all the problems that come with SQL. So if we were going to use it, here's our logical model. We can remove the Elasticsearch cluster and stick in BigQuery, simplifying the overall architecture. And that's it. All right. Now, was I just talking to myself the whole time?
No, I heard you at least, and
right.
I think we all heard the robot voice that came through while we were having audio issues. Would you be able to give a brief overview of the query page, being able to query active data directly, and maybe also touch on the active data recipes a little?
Oh, there is so much. Okay, so active data provides a service, and I've listed the few operators that it can do, which means we still have the problem of detailed analysis, and that is the role that active data recipes has, which is go to active data, grab the subset of data that we do need, pull it locally, and then process it a bit more so that it's useful. And I'll have to, I don't know if it's still at active data recipes or if there's a secondary. Oh, I don't know.
So I have adr-dev.herokuapp.com, but I don't know if that is the.
I think it's active-data-recipes.
Okay.
And so the great thing about this is not only does it the deeper analysis, but it also provides them in bundled recipes. So if you are looking for a particular solution, then you can go there and see what solutions have already been written. And let's write a query. So the active data query tool is probably the ugliest IDE that you've ever seen. But once it started working, I don't care. What it does is you write in this text box and it just literally sends this content to the endpoint and shows you the result. So we have our unit tests. And if we do a query like this, just say from unit test, it'll automatically limit you to 10. But you can see what a unit test record would look like.
I can only see your first slide, Kyle.
Oh, I have to share specifically that one. Share this one. So everyone see the from unit test?
Yep, I can see that.
And then we can go over what tech is in there. But it's big, it's a large document, and you really have to know what you're looking for first before you go and know what properties look for. We can do things like, and we can aggregate. Just count the records. Now let's see how many unit test records there are in ActiveData today. So we keep about 6 or 7 weeks of unit tests, and if there were commas in there, that's about 4 billion unit test records. What else would you like to see? I'm amazed that a live presentation on a live system is working.
Are there any dashboards that are built off of ActiveData that would be possible to demonstrate?
Yes, neglected oranges. So neglected oranges are the set of bugs, or yes, the intermittent bugs, or the bugs that track intermittence. We want to see once they have some activity. If they don't have activity for at least 7 days, then we want to label them neglected and see what is happening with them. And so this is what neglected oranges does. So the tree herder data is ingested into ActiveData under the tree herder table. And then that gets queried by this dashboard, which is looking for all the bugs and that have intermittence associated with them. And also going to Bugzilla, there is another ActiveData instance with Bugzilla bugs. It also looks for those intermittents, looks for anything that has not had a comment for 7 days, but is still an active orange, and presents it here. So this is used by our what? I don't know who uses it anymore. Sometimes I get a message when it doesn't work. So there's also fresh oranges.
You're muted, Kyle.
Okay. The fresh oranges is, I forget what the exact criteria is, but there's a certain number of or failures per 2 days, 3 days, and a week. And if it meets one of those criteria, then it shows up here. It shows how long the bug's been around, the current count. Another example. Other questions?
Hey, Kyle. Thanks a lot for your presentation. And just a general question for you, what would you say has been the most challenging part of this entire ActiveData project?
When I first started the ActiveData project, I was very happy and very excited about all the possibilities with so many machines available at your fingertips. Unfortunately, the truth is it's just an operations nightmare. So that's the most challenging thing. I don't think I ever want to be responsible for keeping up a service again. Like, it was fun, I learned a lot, but it's a lot of work. So I certainly appreciate what those people are doing to keep those machines running all the time because now I know what that takes. And you can see the automation, like the ES shard balancer, born from the need to make sure that the actual, like all the queries don't land on a single machine. The spot manager was required because I can't just spin up a few machines, I have to spin up tens. And as the project gets bigger and ingests more data from various data sources, even the spot manager started to be too slow. You can't just connect to one machine at a time when you have 200. Now you have to parallelize the whole thing. So yes, operations, it's work.
I can't imagine. That's awesome. Well, it's great. It's all come together. Pretty cool. So that's awesome.
Yes. So I am kind of happy that if it turns out that BigQuery is not expensive, then it would be great to be able to move to that. Or even just the Elasticsearch service. Like Elasticsearch, we don't necessarily have to maintain our own cluster. There is Elasticsearch as a service, but it's very expensive for the volume of data that we have.
Does anybody else have questions for Kyle?
Oh, Kyle, can you hear me?
Yep.
Oh, yeah, thanks for the talk. That was really good. Just wondering if we want to add new tables to ActiveData, what would we have to do?
Give it a name and tell me where it is. And then what we do is we scan it and pour it in.
Okay, thank you.
So the idea here is that ActiveData can handle any JSON documents. And if they're reasonably well formed, as in the biggest restriction now is making sure that you only have a fixed number of properties, whether nested or not. And so you can't use URL as your property name because first it's not limited, but also you don't know what URLs you might be processing. So if you have a fixed number for any one run of your application, you have a fixed number of properties going into those JSON documents, then it's a good candidate. And the great thing is I don't have to care what it is because the schema is managed by the machines. So really, it really is what are we going to name it and where is it so that we can ingest it.
Oh, okay, thanks.
Okay. Well, thanks for listening, everyone. And if you have suggestions about what else you would like to know about, because Dave, you mentioned both its applications, but each application is very specific to the person that's interested in it. Like fresh oranges, most of you may have never seen it, or even know how it is used in our daily processes. So it's because it's very, or ActiveData is relatively abstract in that it's just a storage container. The uses are varied, and that's part of the objective is to be abstract like this so that it can be used easily and for many purposes.
That's great. Okay, well, thanks, Kyle. Thank you also, everyone, for attending and for your patience as we work through the audio issues. So as mentioned, look out for an invitation for next month's gathering with Charles Dubec from Wikimedia. Otherwise, thanks again, Kyle. And Kyle, would you be able to share your slides?
On the wiki?
Slide. If you let me know them, I'll distribute them to everybody that's...
Okay, yes. So now that the presentation's done, I will turn them into a PDF and also give you a link. So
perfect.
It's already publicly shared.
Thanks very much. All right. Take care, everybody. And thanks again, Kyle.
Thanks.